So our last major thing to do with complex numbers is to learn how to divide them. So let's kind of look at that. Again, just a reminder, I, right, is defined to be the square root of negative 1, and I squared would be negative 1. So just keep that in your little memory box. And let's consider this division. So I'm taking the complex number 5 plus I, and I'm dividing it by the complex number 2 plus 3i. So what do we do? All right, and this is relatively hard because we have a sum here and a sum up there, so we can't even divide out any common factors. Long division would look really crazy, right? It'd be 2 plus 3i and 5 plus I, and that looks, we can think about how we would do that, how many times does 3 go into I, but it's just crazy. But what we really want to do is, if you go back to the definition, we're looking at 5 plus the square root of negative 1 and 2 plus I times the square root of negative 1. And since that's the case, we now have a radical down to the denominator. And what we learned a few sections ago is we usually don't want a radical down to the denominator. So what we did is we rationalized the denominator. So we did that, I believe it was section 10.5. And we're basically back, because of the definition, to doing the same thing here. So in reality, we actually do not divide complex numbers. What we basically do is we simplify them. We simplify the division by rationalizing the denominator. Of course, what do we need in this case? Since we have an addition statement, I need to multiply by something that's going to help me get rid of that. And back in section 10.5, we realized that that was the conjugate. Matter of fact, we just saw that in the last video, that these two multiplied together, and I think we got 13. So there's your idea. So we don't actually divide. We rationalize the denominator by using the conjugate. Okay, so very familiar idea. We're just pushing I around. So what's the conjugate of 4 plus I? It's 4 minus I. To be in balance, whatever I do to the top, I have to do to the bottom. So 1 times 4 minus I is 4 minus I, and on the bottom we have that product. Now again, you could FOIL that out if you wish, right? But I'm going to take advantage of the fact that we have the difference of squares here, right? That's essentially what that is. So the bottom becomes 4 squared minus I squared, which is 16 minus a negative 1, which results in a 17. So our final answer here is 4 minus I, all divided by 17. And to get us ready for what's you're probably gonna see in your homework and whatnot, remember there are two fractions actually here. There's 4 over 17 minus 1 over 17i, if you would. So we do have a complex number here. The real part is 4 over 17, and the imaginary part is negative 1 over 17. So be aware, there are actually two fractions there. So be careful when you divide out and things of that nature. We got lucky here because there's no common factor floating around anywhere. So we're done. So what about the next one? We have 3 minus 5i down at the bottom, so we have a radical. So we're going to multiply by the conjugate. All right, so the conjugate is the same two terms, different sign. To be in balance, whatever I do to the bottom, I've got to do to the top. So there's my equivalent fraction. Multiplying, we're going to multiply top to top and bottom to bottom. Okay, on the bottom we have the difference of squares again. So that's 3 squared minus 5i squared, and that's a 9 minus 25 times negative 1. And so we get 9 plus 25, and we get 34. So putting this all together, up in the numerator we had 2 and 3 plus 5i, and the bottom is now 34. All right, and we have a product up here, right? This is a multiplication, so this 2 is a factor, and it does share a common factor with the 34, right? 2 goes in itself once and goes in there 17 times. So our final answer in this case would be 3 plus 5i all over 17. And then of course there are two fractions here. So our real part is 3 over 17, and our imaginary part is 5 over 17. And no, not all things turn into 17. Don't draw that conclusion from my two examples there. That was just coincidence. I pray that the next one doesn't turn into 17. Okay, so there you go. So we've done this before. We're just pushing. We're the same idea, same concept as 10.5, but we're pushing an I around. So last but not least, we have our original problem. So we're going to take the conjugate and multiply it to the top and the bottom. So this creates the product 5 plus I, 2 minus 3 up in the numerator, and 2 plus 3i, and 2 minus 3i in the denominator. Okay, the denominator is nice because that is the difference of squares. But the numerator, we got to FOIL that out. So 5 times 2 is 10. My outer gives us a negative 15i. My inner gives us a positive 2i. And last times last would give us a negative 3i squared. Alrighty, so cleaning up the top, we have a 10. These combine up to 13i. And that effectively is going to be a positive 3. And then we're all divided by 4 minus 9 times negative 1 there. And so when we're said and done upstairs, we get 13 minus 13i, and then 4 basically minus a negative 9 turns into 13. So that's pretty nice. Alright, so there's two fractions here, so I can break that up. Everything divides out real nicely, so we end up with 1 minus I. So we got really lucky there. That cleaned up very, very nicely. So we have a real part of 1 and an imaginary part of negative 1, and that's how we divide complex numbers. We actually do not perform the division. We go back to the old concept of rationalizing the denominator with the conjugate, and it turns into a huge multiplication problem and simplifying at the end. Alright, so that wraps that up. Let's go on to look at some higher powers of I.